Welcome to this session on operational amplifiers. Operational amplifiers is the fifth module in our syllabus. Fourth module is that of transistors, but there are two schools of thoughts, whether transistors should be learned first or whether operational amplifier should be learned first. Even though operational amplifier consists of transistors, still an appropriate school of thought is that operational amplifier should be learned first by considering at a block schematic level, and then once the interest is created about the applications of operational amplifier which are far ranging, then the transistor, which is the internal component of the operational amplifier, should be studied at depth. So also understanding of operational amplifier at a block schematic level is very much easy, logical and straightforward, and in fact actually does not require much domain knowledge, whereas transistors require some domain knowledge. Therefore, we have specifically and thoughtfully chosen the sequence to have operational amplifiers first before transistors. So, first of all, why the name is operational amplifier? Prior to that, what is an amplifier? I think that the word amplifier is so generic that even a non-engineer clearly knows that to amplify means to make something big, from small to big. So, a small signal, small input which is available from some kind of actual physical phenomenon, maybe temperature, maybe some kind of pressure changes, etc., is to be converted into an electrical signal first by some kind of transducers, and then that electrical signal which is at small level needs to be amplified so that it can be appropriately used for the end result. Say for example, we can have this mic. The mic converts my audio signal, which is essentially a pressure signal, a mechanical phenomenon, into electrical signal. This mic is a passive transducer. Passive transducer means it does not generate electricity, but with the help of power supply which I have, it makes changes in the voltage which are proportionate to changes in the pressure level. Then this signal is amplified further and given to the speakers which nowadays exist in your cell phone. So, what speaker converts? Speaker converts exactly, a speaker operates in exactly reverse manner that of a mic. It converts electrical signal to pressure signal, wherein you are listening again the same audio. So, in general, sensing circuit, some signal conditioning which also requires amplifiers in it, then amplifier, and then the output circuit is the general phenomenon of any electronic application as such. So, it is for the purpose amplifier. Then why it is operational amplifier? When the chip when transistors were developed in late 40s, various transistorized circuits for different applications were thought of, and designing a big circuit using transistors, resistors, capacitors to a large extent was one of the very critical designing activity. But as there was growth in semiconductor technology, it happened so that instead of requiring everybody to design the same thing, just like reinventing the wheel, a compact single chip solution was made available which contained multiple transistorized amplifier layers, that is called as operational amplifier. And why it is called operational amplifier? Because those days the computers which we have today were not so far developed, and even some analog computers were also thought of, and people were talking about whether mathematical operations can be performed automatically by some system, and in that like addition, subtraction with real variables was thought of, that this amplifier can do. Even multiplication division is also possible using log and log amplifiers, which uses non-linear characteristics of diodes. Therefore, a device which is capable of doing various mathematical operations, hence it is called as operational amplifier. Now, since this subject is at first year level and that too for non-domain students, we would be discussing thoroughly but not with domain specific depth. It is not that we are just discussing it superficially. We will be discussing in such a manner, in a full-fledged manner, so that you understand everything. So, from that point of view, let us talk about what an operation amplifier looks like. So, an operation amplifier is in fact, or in general, as any amplifier must have, it must run on, just like you need food to survive, a device needs power supply to operate. It is dual-ended supply and obviously with respect to a common ground. So, a ground terminal is must for any electrical circuit. It operates on a plus supply and a minus supply. It is plus VCC and minus VEE, but there is a convention that it is also authorized as minus VCC only, and normally it is taken as 15 volt. So, unless otherwise specified, we choose it to be plus minus 15 volt, but it is called as plus VCC and minus VCC. Then this operational amplifier does not work on a single input, but it works on a pair of inputs like this, I will explain in detail, and an output terminal. So, and two input terminals, one is called as non-inverting terminal, why that I will also explain. Other is called an inverting terminal. We give them VA, names VA and VB, and output is VO. So, in henceforth all discussion, we will be dropping these terms like plus 50 microfarad ground. Just like suppose if somebody asks you what you did today, then you never say that I have taken my food, because it is presumed every time. Therefore, in henceforth discussion, just to make the things simple and to have easy interconnection between the different circuit components, we do not show supply because it is always there. So, for further discussion, we restrict op-amp to be a 3-terminal device which is having 2 input terminals and 1 output terminal. And now let us discuss how operational amplifier works. Then, to explain some working of any system in the world, it may be right from a simple drill machine to an aeroplane. The complete understanding is only possible if you are able to do that thing. If you are unable to do that thing, then complete understanding is not possible, it remains at some superficial level. Therefore, in order to explain how op-amp works, I will make one of you to be inside op-amp, and I will give you the sequence of instructions which you will follow, and then once based on that sequence of instruction, the question how op-amp works will not remain, because the instructions are self-explanatory. So, as to make the thing simpler, I am drawing the op-amp size big. You must be contained in that, so it is somewhat more big. So, like this. It is having 2 input terminals. Now, VA and VB. Now, you are inside. What you can do, in fact, even though you are quite competent and intelligent person, but to be precise, your abilities to do are very restricted. Thinking is something which is beyond explanation, but otherwise you can watch through your eyes and act through hands. That's all what you can do. So, now let us give you a very simple description of operational amplifier, which will not be available in any book. You may try for Google search and you will find that you simply don't have it. Now I am just drawing the ground terminal on the right hand side just for some simple purpose. Now let us have one potentiometer, a 3-terminal device like a rheostat you have studied in standard 11 12th. Then you have studied voltmeter. So we put a voltmeter, a digital voltmeter everybody has got now. It is having 2 terminals, plus and minus. So what you do, you will connect this terminal here, this terminal here. So when you look from your eyes on this voltmeter, what you see? So the reading of the voltmeter, this I can say voltmeter 1, and there is one more voltmeter. This I will say as voltmeter 2. So voltmeter 1 will give you what? That is very obvious, that with your both eyes you are supposed to see both things. Watch at 2 places simultaneously. So you can watch this voltmeter 1, you can watch this voltmeter 2. And additionally, with your hand you can change this rheostat position from extreme left on this side, extreme right on this side, and middle. So by changing rheostat, you can change voltage from -15 to +15 through 0, and you can watch this voltmeter and this voltmeter. Yes, so now you are just a robot, we can say, who can watch and control. But there has to be some connection between what you watch and what you control. It should not be random, just like I have found few students. What do? When something is asked in the question paper, in the answer book they write something which is not relevant to the question paper. It is not a proper way. So we must act in a proper way. So what will you do? The instructions given for you are: 1, first watch V1, not V1 I say, watch voltmeter 1. What is voltmeter 1 reading? It is called as VID. It is input differential, which is VA minus VB. So with your eyes you are watching voltmeter 1. With your eyes you are watching voltmeter 1, which will show you reading of differential input VID. Then now as regards to voltmeter 1, inputs are coming from outside which are beyond your control. You can just see. Whereas for voltmeter 2, you can see as well as you can change by using your hand. So what you do? Watch voltmeter 2, that is VO, but you are not supposed to only watch, you are also supposed to act upon and try to change the variable knob of voltmeter so as to ensure that VO is equal to 1 lakh. 1 lakh, I am deliberately choosing a general figure, not specific. It is called a differential gain, but if you talk in terms of always some variables and symbols, our understanding is limited. So VO is equal to 1 lakh into VID. So what you do? Step 1, watch voltmeter 1, VID. Step 2, watch voltmeter 2, current VO. Then see whether VO, it may be accidentally, a student may get some question paper and he may accidentally write something which may prove to be correct. So what I will say, watch, then you may, after the lecture you may feel that why I told watch first and not act. Watch voltmeter 1, watch voltmeter 2, check whether VO is already 1 lakh VID, maybe coincidentally, then you are not expected to do anything, just like accidentally you can pass. So check whether it is there. If not, say, means I will give an example. Suppose if when you start, a starting point, the potentiometer may be anywhere. So suppose if VA is something, VB is something, and VA minus VB is say 10 microvolts. VA minus VB is 10 microvolts. So VA minus VB is nothing but what we call as VID. So VID is 10 microvolts. You also watch voltmeter 2. You also watch, because before acting you must observe. So you also watch VO, and maybe accidentally, we don't know, VO may be say 0.5 volts, maybe at initial place. Then VA minus VB, VID is 10 microvolt. So what is 1 lakh into VID? 1 lakh into 10 is 10 lakh microvolt, that is 1 volt. What is VO? So VO is 0.5 and 1 lakh into VID is 1. So VO is not 1 lakh into VID. So the current output is less than what is expected. So for that purpose, what is in your hand? You are having a variable knob in your hand which you can vary. What you want, 1. What you have, 0.5. So if what you want is more than what you have to move right. And if what you want is less than what you have right now, you have to move left. So what will you do? You will watch now here also, because that may also change, and here also, and adjust the knob so that output becomes 1 volt. So if VID is 0.5, VO becomes, so if VID is 10 microvolt, VO becomes 1 volt. Now after some time, there may be some change in the input, and VID may become 20 microvolt. So VO right now position is for 1 volt. So VID has increased. So what you are supposed to do? You have to move again right. Like this way it continues. VID becomes 140 microvolt. What will you do? You will move right, make 14. VID becomes 150 microvolt. What will you do? Move right, output will become 15. VID becomes 200 microvolt. What will happen? What you want? 20. What you have? 15. What you are supposed to do? Move right. But you have reached extremity. Plus 15 means on the right, when you move on the right hand side most extremity, you reach plus 15. You want 20, just like in JEE, you want 360 marks, but you don't get, because there is maximum limit for what you can achieve. Like that, so what is your way of working, which is called as algorithm in scientific terms, is observe VID, observe VO, try your level best. Now I have changed my words, not make, but try your level best to ensure that VO is equal to 1 lakh into VID. Try your level best. I have not said that you ensure, because you can't ensure. Try your level best to have VO is equal to 1 lakh into VID. You are successful till VID is 150, VO is 15. On the negative side, if VID is minus 150, VO is minus 15, and beyond that you cannot work. So now I hope you understand how op-amp works. So we remove you. So this is just like a walker. For a baby, walker is needed to start walking. But after baby is able to walk successfully, the walker is not to be carried throughout the life. Walker is to be thrown away, even though we can say it is use and throw is not proper. But in case of walker, walker is to be thrown away. Like I have thrown this concept away. Now there is no need for anybody to imagine somebody, because A can imagine B is there, B can imagine C is there, and everybody can imagine that somebody else is there, which is automatic. So now a question is asked. So plus 15 minus 15, that rheostat, that I is the voltmeters, everything is removed, and now we can very simply have the method with which the operation amplifier works. That is, how operation amplifier works? In a single sentence, if a question is asked, how op-amp works, then the answer is op-amp has got 3 terminals, VA, that is non-inverting, VB inverting, VO output. Then op-amp tries its level best to have VO is equal to 1 lakh into VID. So I again write 3-terminal device plus minus and VO plus is VA minus is VB, just names are given, and VO. So the input on which op amp works is differential input, not single input. So VA minus VB. Then what is op amp equation? Op amp equation is more simple, that VO is equal to 1 lakh into VID, but this is not unconditional equation. There are stringent conditions put, that subject to condition that it is in between plus 15 and minus 15. So op amp works in such a manner so as to ensure VO is equal to 1 lakh into VID, where VID is VA minus VB, subject to condition, subject to limits, that VO is restricted at plus 15 on upper side and at minus 15 on lower side. So this is open loop operation of operation amplifier. In open loop operation, op amp is used only as a comparator. Normally op amp is not used in open loop situation. Op amp is used with feedback. Now this 1 lakh also I have taken the numerical value, because differential gain is normally in this range, and initially if symbols are taken then it creates confusion, but now it is very clear. So 1 lakh is not so specific, it is in the range of few lakhs. So we use the term, it is called as AD. Why A subscript D? Because it is differential gain. Op amp works on VA minus VB, AD into VID. Work equation of op amp is VO is equal to AD into VID. So AD is called as differential gain. So I deliberately put it with different color. VO is equal to AD into VID, subject to condition that it is plus minus 15 volts. Again I would like to clarify, it is plus 15 not fixed, it is plus minus VCC. So if plus VCC is 20, it will be go to 20. If it is 10, it will go to 10. But unless otherwise specified, we normally use it plus minus 15, but it can be changed also. Otherwise, that nobody should take a headstrong message that it is plus minus 15 only. Now with this, we will go for a very simple circuits with feedback, and I will explain the working of the circuit. Prior to that, I will give the name of the circuit and then we will discuss, so that when I give the name, you will get some hint if you are listening. I hope that everybody is listening with appropriate attention. If you are listening with full attention, when I give the name, then you must be able to understand what the circuit will do before I tell. So now we go for the feedback. What is feedback now? Something should come from output to one of the inputs, and in case of op amp it comes to negative or inverting input. It can come to non-inverting input also, but right now that is not our focus. If time permits, we will discuss that later on. So now today, right now we start with the most simple circuit. In the syllabus, the standard syllabus, the sequence is different, but I do not act on the sequence. It should be case with everybody of you. You must be able to define the sequence and not act on the defined sequence. So now we will be discussing the circuit which uses feedback, that is called as voltage follower. So I hope that name is very clear, voltage follower. Now we draw the circuit. The most simple circuit with feedback. One more thing which is to be used right now, it is not required, but in general is op amp's input is having very high input impedance transistors. So op amps do not draw any current. Op amps do not draw any current that is required in further circuit analysis. For this it may not be required. Now if a question is asked, determine VO, how will you proceed? We go by a simple method. Op amp is there, so op amp definition will not change. So VO is equal to AD into VID. What is VID? VID I write once again, AD into VID, that is equal to, I rewrite all the steps. So VO is equal to AD into VID. What is VID? What is VID? VID is VA minus VB. So I write the full equation. So VO is equal to AD into VA minus VB. It is the equation because of amplifier. Because what happens in amplifier? Inputs of the amplifier define the output of the amplifier. Input terminals are sensed by op amp and output terminals controlled by op amp. So op amp defines output based on input, but I have got a feedback connection. So because of that, what happens? This is one of the inputs. So who decides that? Output decides that. So for if we go through op amp working, op amp defines, or VO depends on VA and VB, or VO depends on VID. VID is VA minus VB. So indirectly VO depends on VA and VB. VA is fixed, separate, VB is here, and because of this direct connection, VB depends on VO. So VO depends on VA and VB, and VB depends on VO. So what is the dependency? Most simple circuit. So what is VB? VB is VO. There is nothing to explain. This is so simple that you will say, is it too simple, or whether I am teaching just like at a primary school level? It's really too simple. So what is VO now? VO is equal to AD into VA minus VO. Why? Because VB is VO. This is how it, why it is so, as VB, this is because as VB equal to VO due to feedback. Due to feedback, VB equal to VO. Now we expand. Now it is high school level problem. We expand it. VO is equal to AD VA minus AD VO. Now correct terms on one side. So VO plus AD VO is equal to AD VA. So I can write VO into bracket 1 plus AD, right? I think we can take this step, is equal to AD VA. Then next step is also quite simple and straightforward. That is VO is equal to AD upon 1 plus AD into VA. Is it right? There is nothing great. And after this, we can go for next simple step. The next simple step is divide numerator and denominator by AD. So 1 upon AD plus 1. So I simply write 1 upon 1 plus 1 upon AD. So what is VO? VO is equal to 1 upon 1 plus 1 upon AD into VA. Now let us comment on this term in the bracket. If AD is 1 lakh, it will be 1 upon 1 lakh. So it will be 1 upon 1 point. How many times zeros? 1 point. 1 upon 1 lakh. 1 upon 1000 is 2 zeros. 1 upon lakh is 4 zeros and then 1. So 1 upon 1.00001, which is approximately equal to 1. Therefore, we can say VO is approximately, but very well, as good as. VO is as good as, just less than VA. VO is just less than VA. Therefore, output follows the input. It is called as unity gain buffer also, or voltage follower. So, output follows the input. Now, a simple question. If Vi is 10 volt, what is Vo? Just 10, 9.999 or so. If Vo is 12, what is Vo? If Va is 12, what is Vo? Around 11.99 or so. If Va is 15, what is Vo? 14.99 or so. If Vo is 20, if Va is 20, what is Vo? It will not be 19 point something, because op amp can't deliver beyond plus 15. So, if Va is 20, Vo will be 15 only. It will be 15 only. I hope the concept is very clear. Now, we move on next circuit. I hope that we will go through this feedback formulae, and after that we will go for a simple, what we can say, thumb rule. It is not a scientific, but for working purpose, it is most of the times you find that what is scientific is not for good working purpose, and what is for good working purpose is not scientific. This is a deadlock which we must resolve appropriately by understanding scientific technique as well as by understanding thumb rule. So, now we go for a I write the name non-inverting amplifier. That is, it is something which is having a positive gain. Non-inverting amplifier. It is very simple. See, you will find such simple circuitry which you have never studied. This is now called as V in. That VA in the last example also you can call it V in, because VA and VB are internal names. VA and VB are internal names, so I write them here, and externally you can give some names as you, just like local and global variable. Now, this is R1, this is RF. One important thing is that op amp does not draw any current. So, you just disconnect from your mind, not actually, because if you actually disconnect, it will not work. From your mind you disconnect, means the purpose of disconnection is that no current goes inside op amp. So, using Kirchhoff's laws you can work. Now, how the system will work? Let us start straightforward again. What is VO? Same AD into VA minus VB. What is VA? AD into VA is V in, you are directly connected, no question of calculation. What is VB now? Oh, I made a big mistake, not a mistake, just we can say, I will not say that I have just done to check your attention, because it is not a live classroom. So, it is a simple manual error. So, VA minus VB. So, what is VA? VA is V in. What is VB now? Now, op amp terminal does not draw any current. Op amp terminal does not draw any current. Because of that, what would be VB? VB would be simply potential divider arrangement VO, RF, R1, ground. So, you have studied this potential divider. If this is ground, if you connect something as V, I will use some other term, VC, this is, I will use R so that no confusion, RB and RA, and what is this is VD. So, what is VD? VD is equal to RB upon RA plus, actually it should not be told, but I just telling, because it is assumed, RA plus RB into VC. So, like that now, what is VB? VB will be R1 upon R1 plus RF plus R1, either way, into VO. So, V in minus, now I will use that, R1 upon RF plus R1 into VO. Is it clear? So, I think other things I write about because I need the board space. So, here no rocket science, no complex things like Einstein formula. What is VO? VO is AD into VA minus VB. What is VA? VA is V indirectly. What is VB? VB is potential divider R1 upon RF plus R1 times VO that I have put. So, I restart working. VO is equal to AD. Just what I will do? Just multiply inside, very simple way, AD V in minus, I take in the numerator, AD R1 upon RF plus R1 into VO. Now, it is some equation which is again high school level equation. But how do we proceed? We are somewhat allergic about denominator. Denominator is something what we do not like. Integration is something what we do not like. PNP transistor is something what we do not like. NPN transistors we like, derivatives we like, numerators we like. So, get rid of denominator. It is not that it is something different, just like left and right, right? Normally, people prefer right hand and not left hand. It is just like, so you get rid of denominator by multiplying with the denominator. So, what we get? RF plus R1 VO is equal to AD V in minus AD R1 VO. Again high school level, no rocket science, no rocket science, right. So, that AD VO, AD R1 VO term should come on the left hand side, AD R1 VO term will come on the left hand side. So, what we get? RF plus R1 plus AD R1 VO is equal to AD V in, AD V in. I think till that time everything is fine. Now, what we can have? We can have R1 common here. Everything is fine? Oh, or some mistake, there is some mistake which you should have told me. It should not have happened actually, that this should come here also. That is AD into RF plus R1 minus AD R1 VO. Now, it looks fine. So, take it on this side. So, RF plus R1 plus AD R1 VO is equal to AD into bracket RF plus R1 V in, and then straightforward. Now, you want VO, so again take it to the other denominator. So, the final equation will be VO is equal to AD into RF plus R1 upon RF plus R1 plus ADR1 into Vn. So, it is very simple, nothing great here. Now, AD is quite large, around 1 lakh. So, divide numerator and denominator by AD. So, what we get? VO is equal to RF plus R1 upon this ADR1. So, when we get divided by AD, this becomes R1. So, I write on this side just, and plus RF plus R1 upon AD into V. Now, AD is quite large compared to AD is quite large when we ignore, suppose that can you ignore 1 mark if it is less and you are on the verge of passing? You can't ignore. When you ignore, when it is ignorable. So, now this is R1, this is R1. It is normally in the range of some kilo ohms. So it is maybe few thousands. It is again in kilo ohms upon AD. So something in the terms of thousands, something in terms of thousands upon lakh. So thousands and something 0.01 or so. So it is, so why we neglect? It is not zero. AD is not infinite. So RF plus R1 upon AD is very much negligible compared to R1, so you can ignore. And finally, when you ignore, it is approximate, not the final answer. So it is approximately, but very, very close to. So by ignoring the term, the negligible term, what we get? VO is equal to RF plus R1 upon R1 into Vin. If we divide it separately, VO is equal to, this is RF1, R1 and 1. So I just write in the reverse sequence, 1 plus RF upon R1 into Vin. I will say it is not equal to, it is approximately equal to, but very, very close. So if RF is 2 kilo ohm, R1 is 1 kilo ohm, then RF upon R1 is 2, 1 plus 2 is 3. If Vn is 2 volt, VO would be 2 into 3 approximately equal to 6 volt. So it is called as we started, it is called as non-inverting amplifier. Non-inverting means input is positive, output is positive. This is called as non-inverting amplifier. Now a simple question, if Vin is 4 volts, what is, if this is 2 kilo ohm, this is 1 kilo ohm, ratio is 2, gain is 3. If VO is 2, if Vin is 2, VO is 6. If Vin is 4, VO is 12. If Vin is 6 volt, what is VO? VO would be 18, you calculate, but it can't become. So if Vin is 6 volt, VO will be plus 15 because op amp can't go beyond plus 15. If Vin is minus, you can give minus input, minus 3, minus 9, minus 4, minus 12, minus 5, minus 15, minus 7, minus 11, minus 21 you can't have, minus 15. So it is non-inverting amplifier. Now we go for inverting amplifier. Then after going for inverting amplifier by this standard technique, we end the lecture, and then in the next lecture I will show you all these very tedious calculations actually are not required. Why we are doing it now? Because you must know the real reason for the thumb rules which we are going to have in the next lecture. So just we have inverting amplifier now. So obviously there will be negative gain. So inverting amplifier is quite simple, very simple actually. Just I draw on that side so I get the board space. This name I give VA, this name I give VB, internal pin name. VA is grounded, so it is 0, and VO, this is V in. So input you give here, this is R1, this is RF. Now we proceed in the same manner. It is very, very simple. Number 1, state equation, VO is equal to what? AD into VID. What is VID? VA. What is VA? 0. What is VB? VB, right. So VO is equal to minus AD into VB. VO is equal to minus AD into VB. But what is VB now? VB also is decided by V in, VO and Kirchhoff's law. This doesn't draw any current. So with this now, how you can calculate V? How you can calculate this one? If current flowing through this is I1, this current is IF. Since no current is drawn by op amp, I1 must be equal to IF. So using Kirchhoff's laws, current incoming equal to current outgoing because there is no current going here. So what is I1? V in minus VB upon R1. What is IF? VB minus VO upon RF, and those are equal. So straight away it is very simple, again very logical. I think that after 5-6 years this will be a thing in high school level studies. So V in, what is I1? V in minus VB upon R1 is equal to VB minus VO upon RF, right. So, as I again say, get rid of denominators. So, RF V in minus RF VB is equal to R1 VB minus R1 VO. So, what you want now? You do not want VB. So, you just replace VB in that term. So, what is now? What is this? So, you take RF VB on this side, take this on the other side and swap the sides. So, R1 VB plus RF VB. So, it is very simple again. R1 VB plus RF VB is equal to, this you take on this side, this you take on this side, RF V in plus R1 VO. So, VB is equal to, or we make it right again, R1 plus RF VB is equal to RF V in minus R1 VO. So, VB is equal to RF V in minus R1 VO upon R1 plus RF. So, that simply you have to put here, that is all, it is the end. So, what is VO? VO is using, this is equation 2, this is equation 1. Using 2 in 1,